Thank you for joining me today, mathematicians, as we try to find the domain of f of x is the square root of x plus 4 over x minus 2. So remember, if we're trying to find the domain of the function, what we're trying to do is to find all the values that can be plugged into the function where we get out a unique answer. So now, as we're doing this one, we'll notice that this is a more complicated function because it involves smaller functions. So as we want to find the domain of this, what we're going to do is we're actually going to break it into pieces first. And so what I notice is that I have a function, say x minus 2. Since I have f already, I'll call this g of x. I have a function x plus 4, so let's call that h of x. And I have the function square root, so let's call that k of x. And so what I get is that I can combine these three functions in order to create these functions. And the reason why I want to do that is because I can focus on the domains of these functions and rules about constructing domains of new functions in order to get the domain of this function out without having to do everything at once. And again, the smaller pieces, and the more pieces that we break things up into, the less room for error there's going to be. So now as I look at g and h and k, the first thing I want to notice is that I can rewrite f as, well, the square root of x plus 4 is actually k of h of x. And then the x minus 2 is just g of x. So what I'm going to have is that f of x is going to be k of h of x, all divided by g of x. Alright, so now in order to combine these, what we need to know is that if we're going to be finding compositions of functions or quotients of functions, and we want to find the new domain, we would have seen in class that the domain of a function divided by a function can be found as, well, in order to get an answer out when I plug it into f over g, I have to get an answer out when I plug it into f, so I would have to be in the domain of f. I'd also have to get an answer when I plug it into g, so I'd have to be in the domain of g. And furthermore, I can't divide by 0, so I'd have to be in the set where g of x is not equal to 0. So if I want to find the domain of f over g, I would find the domain of f, intersect the domain of g, intersect all the points where g of x is non-zero. In a similar way, we could say that the domain of f of g of x is going to be, well, I have to be able to plug x into g, so I have to be in the domain of g. Now notice that I'm not plugging x directly into f. Instead, what I'm doing is plugging the answer of g into it. So I'd have to be in the set of all x, where g of x is in the domain of f. And so I can find the domain of a composition by taking the domain of the inside, intersect where the inside function is in the domain of the outside function. And so we're going to use that as we find the domain of this function here. So now as we try to fill in our domain, what we need to do is we decided we needed the domain of g, the domain of h, and the domain of k. So I'm going to say that the domain of g is all x that I can plug in such that x minus 2 gives me out a unique answer. Well, any real number minus 2 is still a real number, so the domain of g is just the set of real numbers. If I take the domain of h, we again just get, well, any number plus 4 is again just a real number. Therefore, the domain of h is all real numbers. On the other hand, if I take the domain of k, notice that the square root of x is not defined for negative numbers, because if I try to do that, I won't get out a real number. Therefore, this is only defined for non-negative numbers. That is, the domain of k is the set of all x, such that x is greater than or equal to 0. Or if you'd like that in interval notation, it'd be the interval including 0 to infinity, but not including infinity. And so I would get the domain of g is r, the domain of h is r, and the domain of k is all non-negative numbers, or 0 to infinity including 0. Now, as we combine those, what we need is, we need to remember that in order to have this function work out, I need the top function to work out. So we'll start there, and we'll say, what is the domain of k of h of x? Well, I already found the domain of k, and I defined the domain of h. So that now if I want to find the domain of k of h, I have to say, where is h in the domain of k? So that would mean that The domain of K is everything greater than or equal to 0, so I would need H in the domain of K. So what I need is, I need x plus 4 to be in the domain of K, which means that I need x plus 4 to be greater than or equal to 0, which means that I need x to be greater than or equal to negative 4. Therefore, the domain of the top of this function is all x such that x is greater than or equal to negative 4. Now that we know the domain of the top of this quotient, we have to find the domain of the bottom, but we already know that the domain of G is all real numbers. Now when we're combining the quotient, we would say that it has to be in here and in here, so at that point it would just have to be in here because G is defined for all real numbers, it doesn't restrict us anymore. However, we also have to have that we can't divide by 0, so in addition to this, we would also need that G of x is not equal to 0. And so since G of x is x minus 2, we would need G of x to be not 0. So what we would do is we would actually solve when is G of x 0. Well, G of x is 0 if x minus 2 is 0. So that is if x is equal to 2. So we know that G of x is 0 when x is 2. Therefore, what we need is x to be not equal to 2, because when it's equal to 2, my function is not defined, but anywhere else, this doesn't add an extra restriction. So now what we get is if we combine these two, we get that the domain of these two is it has to satisfy that x is greater than or equal to 4, and that x is not equal to 2. So then we're going to get the domain of f is going to be the set of all x such that x is greater than or equal to negative 4, and x is not equal to 2. Now, if I want to combine those together, I can leave that right there and say that is my domain. It's a set of all x greater than or equal to negative 4 where it's not equal to 2. Now, if I want to combine this and write this in interval notation, what I would get is, okay, well, I need x greater than or equal to negative 4 and not equal to 2. So what I would have is that the domain of f is going to be, I'm going to include negative 4, so I'm going to use the square brace, and I'm going to get all the way up to positive 2. I'm not going to include that, so I'm going to use the rounded parenthesis, and I'm going to say union 2 all the way up to as large as we can get, so up to infinity. Again, we're not including 2 because it's not in our domain, and we're not including infinity because it's not a number, therefore it's not in our domain. And so we get the domain of f is precisely just negative 4 to 2, union 2 to infinity. Thank you for joining me today, mathematicians. I hope you enjoyed this, and I hope you learned something along the way. If you did, make sure to like the video and to subscribe to the channel down here. This will help make sure that other people get to find this video so that they can also get help on calculus.